Hello everyone, this is Math with Zanger. Welcome to our last video for AP Pre-Calculus. 0.4 Sequence and Series. For this part of the unit, we will cover three main ideas. There are definitions, arithmetic sequences, and geometric sequences. A sequence is a list of numbers written in a specific order. We usually write the term as A1, A2, A3, A4, and so on. Each term has a position in the sequence. The domain is the positive integers. Because the first term is term 1, the second term is term 2, and we continue from there. If the sequence continues forever, it is an infinite sequence. It only has the first n terms, then it is a finite sequence. Now we introduce the summation notation. The symbol of sum, called sigma, means we are adding terms together. In this expression, I is the index of summation. The bottom number tells us where to start and the top number tells us where to stop. So the sum from I equals 1 to n of an, which means a1 plus a2 plus a3 plus all the way up to an. These are some basic rules for working with summations. First, if we add the same constant, c, n times, the sum is cn. Second, if every term is multiplied by a constant, we can factor that constant outside of summation. Third, if we are adding two expressions inside the summation, we can split them into two separate sums. And the same idea works for subtraction. These rules help us simplify summation expressions. So, a series is the sum of terms of a sequence. The difference is simple. A sequence is a list of numbers, and a series is what we get when we add those numbers together. For example, if the sequence is A1, A2, A3, and so on, then the series is A1 plus A2 plus A3, and plus all the way to AN. And later, we will use series to find sums of arithmetic and geometric patterns. Now, we're looking at arithmetic sequence. An arithmetic sequence is a sequence where the difference between each pair of consecutive terms is the same. The repeated difference is called the common difference, and we usually write it as d. For example, if every term increases by 3, then the common difference is 3. If every term decreases by 2, the common difference is negative 2. So arithmetic sequence change by adding or subtracting the same number each time. To find any term in an arithmetic sequence, we can use this formula, an equal to a1 plus n minus 1 times d. Here an means the term we're trying to find, a1 is the first term, n is the term of number, and d is the common difference. The reason we use n minus 1 because from the first term to the n term, we add the common difference n minus 1 times. So this formula helps us find term without writing out the whole sequence. Now we are finding the sum of a finite arithmetic sequence. The formula is Sn equal to n over 2 times a1 plus an. Here, Sn means the sum of the first term. Here, Sn means the sum of the first n terms. N is the number of terms, a1 is the first term, and an is the last term. The idea is that we're taking the average of the first and last term, then multiplying by the number of terms. So the formula is useful when we need to add many terms in an arithmetic sequence quickly. Now we're looking at the geometric sequences. A geometric sequence is a sequence where the ratio between consecutive terms is always the same. That repeated ratio is called the common ratio, and we write it as r. For example, if each term is multiplied by 2 to get the next term, then the common ratio is 2. So arithmetic sequences add the same number each time, but geometric sequences multiply by the same number each time. To find any term in a geometric sequence, we use this formula, an equal to a1 times r to the power of n minus 1. Here, an is the term we want to find, a1 is the first term, r is the common ratio, and n is the term number. The reason the exponent is n minus 1 because from the first term to the nth term, we multiplied by the common ratio n minus 1 times. Finally, we are finding the sum of a finite geometric sequence. The formula is Sn equal to a1 times 1 minus r to the power of n over 1 minus r. Here Sn means the sum of the first n terms, A1 is the first term, R is the common ratio, and N is the number of terms. We use this formula when we want to add many terms in geometric sequence quickly. One important note is that R cannot equal to 1 in this formula because the denominator would not be 0. That's everything for Unit 0, Pre-Calculus. In this unit, we covered 4 main topics. First, we reviewed functions, including what a function is, domain, range, and how functions are written. Second, we looked at properties of functions, such as increasing, decreasing intervals, even and odd functions, and transformations. Third, we studied elementary functions, including power, exponential, logarithmic, trigonometric, and inverse trigonometric functions. Finally, we cover sequence and series, including arithmetic and geometric sequence, summation notation, and formulas for sums. So this unit is basically a foundation for the rest of calculus. From the next video, we will start Unit 1 for AP Calculus AB or BC. Please follow for the rest.